Welcome to Chapter 17, Data Mining. Data mining attempts to discover patterns, trends, and relationships among data, especially non-obvious and unexpected patterns. The place to start with the data warehouse, a huge database designed specifically to study patterns in data. It is not the same as a database companies uses for their day-to-day operations. Instead, it should combine data from multiple sources to discover relationships, contain accurate and consistent data, be structured to enable accurate responses to queries, allow follow-up responses to specific relevant questions. A data mart is a scaled down or part of the data warehouse structure specifically for one part of the organization, such as sales. Once a data warehouse is in place, analysts can begin to mine the data with a collection of methodologies. Classifications analysis attempts to find variables that are related to the categorical, often binary variables. Prediction tries to find variables that help explain the continuous variables rather than categorical variables. Cluster analysis tries to group observations into clusters so that observations within the clusters are alike and the different clusters are not alike. Market basket analysis tries to find products that customers purchase together in the same market basket. Forecasting used to predict values at time series variables by extrapolating patterns, see historical data in the future. Numerous software packages are available that perform various data mining functions. Classification methods. One of the most important problems studied in data mining is the classification problem. This is basically the same problem attacked by regression analysis, but now dependent variables is categorical. Each of the classification methods has the same objective: to use data from extrapolating various to classify each record, person, company, or whatever into one category. Data partitioning plays an important role in classification. The data set is partitioned into even three distinct subsets of algorithms are applied. The first subset, usually with 70 to 80% of the records, is called the training set. The algorithm is trained with data with the training set. The second subset, the testing set, usually contains the rest of the data. The model from the training set tested on the training set. Some software packages might also let you specify a third subset called the prediction set, where the values of the dependent variable are unknown, and you can cause the model to classify these unknown values. Logistic regression. Logistic regression is a popular method for classifying individuals given the value of a set of explanatory variables. It estimates the probability that an individual is in a particular category. It uses nonlinear function and explanatory variables for classification. It is essentially regression with binary 0 to 1 dependent variables. For the two category problems, the binary variable indicates whether an observation is a category 0 or category 1. Logistic regression. The logistic regression model uses a nonlinear function to estimate the probability that the observation is in category 1. If P is the probability of the being in the category 1, then the following model is an estimate. Logistic regression. This equation can be manipulated algebraically to obtain the value. The equation says that a natural logarithm of p divided by 1 minus p is the linear function of the explanatory variables. The ratio of p minus 1 minus p is called the odds ratio. The logarithm of the odds ratio, the quantity of the left side of the equation. The logic regression model states that log it is a linear function of the explanatory functions. The goal is to interpret the the regression coefficients correctly. If a coefficient b is positive, if it is x increases and the log odds increase, so the probability of being in the category 1 increases. The opposite true for a negative b. Just by looking at the signs of the coefficient, you can see which x are positively correlated with the being in the category 1, the positive b. In the same situation, the primary objective of the logistic regression is to score members given their x values. Those members who score highest are the most likely to be in category 1, those in category 0. Scores can be used to classify members using a cutoff probability. All members who score below the cutoff are classified. Classifying lasagna's tiers. Objective: to use logistic regression to classify users as tiers or non-tiers and to interpret the resulting output. Solution: the data file contains some data set from Chapter 3 of 856 people who have had their tiers who not tried a new company frozen lasagna. The categorical dependent have tried, and several of the potential explanatory variables contain text as shown below. Because stat tools require all numerical values, the stat tool dummy utility was used to create dummy variables for all tests and variables. To run logistic regression, select logistic regression from the stat tools and run and get the following results. Below is the coefficient output in the classification summary shown below. To create these results, the explanatory variables in which a row are plugged into logistics regressions equations, which result in an estimate of the probability of the person in that tier. The last part of logistic regression output lists all the original data and their scores. Explanatory variables for a new people, those whose tier's status is unknown, could be fed into the logistic regression equation to score them. Logistic equation is being used as the tool to identify the most likely tiers. Discriminant analysis. Stat tools include other classification procedure called discriminant analysis. This is a classical technique developed by many years ago, still used. It is somewhat similar to logistic regression and has same basic goals. However, it is not prominent in data mining discussion and logistics regression. The neural network methodology is an attempt to model the complex behavior of human brain. It sends input the values of explanatory variables through the complex nonlinear network to produce one of the outputs, the values of the dependent variable. It can be used to predict a category dependent variable or a numeric dependent variable. The biggest advantage of the neural net is that it often provides more accurate predictions than other methodology, especially when that. However, neural nets do not provide easily interpretable equations where you can see as contributions of the individual exploratory variables. Each neural net has an associated network diagram like the one below. The figure assumes 2 inputs and 1 output. The neural network includes a hidden layer in the middle of the 2 hidden nodes. Scaled values of the inputs enter network. They are weighted with W. At the hidden nodes, the sums are squished by an S shape. The squished values are then weighted and summed, and the sum is sent to the output node. The neural network is trained by sending many sets of inputs, even the same input multiple times through the network, and comparing the outputs from the net known output values. The stat tool does not implement neural networks, but the neural tools add-in does. Objective: to learn the neural tools add-in work and compare its results through the logistic regression. Solution: the data file is a different file from used in logistic regression in 2 ways. No dummy variables are necessary. The neural tools are capable of dealing with text. There is a prediction data sheet with the second data set of 250 to be used in prediction. The first step is to create two data sets called train, test data, and prediction data. We have tried as dependent categorical persons as unused and the other variable dependent numerical thing. To train the data in the train data set, activate the data sheet, click train and neural tools ribbons and fill out the tab accordingly. Click the train button on the model, set it up. Results will appear something like this. Once the model has been trained, it can be used to predict the unknown value of the dependent in the pair. Activate the prediction data, click predict on the neural ribbons, and then fill out the resulting error. Click the prediction button. Neural tools run each case in the prediction data sheet through the trained net and displayed thing. Each percentage shown here is the probability that prediction is there. Naive Bayes, simple classification method. Very different from logistic regression and neural networks, can be used for text mining. Basic idea: find the condition probability of a given set of exploratory x values, given that the dependent variable is 0 or that it is 1. Probabilities calculated from the observed training data from all observed sets, x values. For the new observation, we look at these probabilities for the exploratory x values. To see how naive Bayes method can be implemented using Excel formulas and compare the results to logistic regression. Data are also for in the design. Training set consists of 700 of the 850 observations. The other 150 used for testing. All numeric values have been based on their quartiles. It looks like this. Classification trees, some kind called decision trees. Intuitive methods that is capable of discovering nonlinear relationships. Not available in any software that accompanies the book. Basic idea: split a box of observation into 2 or more boxes so that each box is purer than the original box, meaning that each box is more nearly yes than no, or vice versa. Each of these boxes can be split on another variable or even the same variable to make them pure. This split continues until the boxes are either sufficiently pure or they contain few cases. The attractive aspect of the method is that the final result is a set of simple rules for classification. A final tree might look like this. Measure classification accuracy. Of all testing rows predicted to be yes, the percentage of where dependent variable is, specifically also called true negative rate. Of all testing rows, there is a dependent variable is no percentage that are correctly classified. Sensitivity, also called a true positive rate. Of all testing rows that where the dependent variable is yes, the percentage of that is classified. Measures of classification. Typically a graph that true positive rate versus the false positive rate. Lift, a measure that increases the number of purchasers reached by choosing a classification technique over a random approach. Classifications with rare events. Classification methods are often used on data sets with rare events. Most packages include neural tools accompany predictions of the new observation with the probability that the predictions are correct. Even if all those probabilities are above 50%, you can still sort on the probability column to see the predictions that are least likely to be correct. Then if you are forced to choose some observation, you can choose the ones with the lowest probability. In supervised, clustered methods, and supervised data mining techniques, there's a dependent variable the method is trying to predict. The classification methods discussed as far are supervised data mining techniques. In unsupervised data mining techniques, there is no dependent variable. Instead, these techniques search for patterns and structures among all variables. One popular unsupervised method is market basket analysis, also associated analysis, where patterns of customers purchased are examined to see which items the customers tend to purchase together in the same market basket. Probably the most common unsupervised method of cluster is known as circles as segmentations. It tries to group entities, customers, companies, cities into similar clusters based on the value of their variables. There's no fixed group like this, and it tiers for non-tiers in classification. Instead, the purpose of the cluster is to discover the number of groups and the characteristics located basically entirely on data. The key to all clustering method is the development of dissimilarity measures. Once a dissimilarity measure is developed, a cluster algorithm attempts to find clusters of rows so that the rows within the clusters are similar and the rows in different clusters are dissimilar. Once an algorithm has discovered the clusters must be understood and possibly named. This is done by exploring the distribution of variables in the different clusters. One of the most popular cluster out is called the k-means, where k refers to the number of clusters. Clustering large cities. To use evolutionary solver to find 4 cities to be used as a cluster center and assign all other cities to one of these clusters. Solution. This sample uses a variation, usually k-means, k equals 4, because its cluster centers are chosen from the existing 49 cities. In a typical k-mean clustering, the cluster centers are not necessarily equal in any of the existence members, but idea is very similar. Regarding the data, if you use raw units, the percentage of African American and Hispanics will drive everything because these values are more spread out than other demographic attributes. You can see this by calculating the means and the standard deviation of the characteristics. To remedy this problem, each demographic attribute is typically standardized by subtracting the attribute's mean and dividing the difference by the attribute's standard deviation. Developing the spreadsheet model, a lookup table. One key to the model is to have an index 1 to 49 for the city so that you can refer to them in the lookup. VLOOKUP function, therefore, a name of ranging. Decision variables. The only decision variable cell appears in the city index range. There are indexes of the 4 cities chosen as a cluster center. Enter any of the 4 cities. Corresponding cities are standardized attributes. You can find the names in the VLOOKUP. Assignment to the cluster center. Each city is assigned to the cluster center that has the smallest distance, therefore find the minimum distance. Sum of the distances objective is minimizes the sum of distances of all the cities to the cluster center for calculated. This is what it looks like. Objective, to see how the cluster analysis can be implemented. In Excel, find this. Solution, the file, shoe sales cluster. File contains data of 3,000 transactions, made to 250 using the pivot table. Do that. K-means procedure, clustering customers of shoes. Return the transaction. Thank you. That was data mining, Chapter 17.